Suppose we know that E is an event for some experiment, and that E occurs 3 out of every 5 times the experiment is run. Determine the probability of E complement. Okay. So when we're reading these things, we don't want to say, oh, PR of EC. Right? If you're doing that, you're doing yourself a disservice, because math, in particular, this sort of notation is meant to be interpreted. This is saying determine the probability E doesn't happen. Right? Probability complement means no, not. This isn't going to occur. So probability E doesn't happen. And if you can read it like that, you're doing really well. Because interpreting things, being able to read a statement and not just have to read out PREC, being able to actually decode it and turn it back into natural language is a good thing to be able to do. It shows that you're really understanding things. So we want the probability E doesn't happen. That's basically what they're asking for. Well, it turns out there is a formula for this. The probability of E complement is 1 minus probability of E. Right? Because either E happens or E doesn't happen, and something's got to happen. Something's guaranteed to happen when you run your experiment. So that's great, except what is the probability of E? Well, they've explained that to me in natural language, so we got to decode this. E happens 3 out of every 5 times, so the probability that E occurs is 3 out of 5, or 3/5. So now I can take that, I can put that in here, so 3/5. If you wanted to, you could convert 3/5 to 0.6, and do 1 minus 0.6. Or you could get a common denominator, 5 over 5 minus 3 over 5. So 2 over 5, or if you're a decimal fan, 0.4. Either one of those is fine. Or you could actually turn it into natural language. There is a 40% chance E doesn't happen when I run my experiment.